Nanofabrication is a difficult art. To practice it successfully and to develop it further, researchers need a highly controlled environment and a variety of instruments and specialty chemicals. The National Nanofabrication Center of the Center for Nanoscience and Engineering provides these to Indian researchers as they endeavor to create new nano devices and process technologies for future applications. But how does the NNFC create the precisely controlled, near-perfect conditions for carrying out sensitive processes? These could go wrong even with the minutest amount of dust, vibrations, electromagnetic interference, ultraviolet light, or other disturbances. The secret lies in several carefully designed and meticulously implemented systems and architecture, invisible to researchers in its work bays. These make the NNFC what it is, a state-of-the-art nanofabrication facility comparable to the world's best. The design features that lend the NNFC its stunning contemporary profile were many months in the making. Its core design team spent nearly 3 years in planning, consulting, and detailing to outline its major constituent systems. These are summarized in a conceptual design document which served as the blueprint for the NNFC's construction over another 3 years. In this module of the guided tours of the NNFC, we will learn about the facility's architecture. Professor Rudra Pratap, a member of the NNFC's core design team, will walk us around the facility, elaborating upon the NNFC's distinctive and essential architectural features and their functionality. As we begin the tour, let's first hear from Professor Rudra Pratap about the tour's agenda and learn why designing architectural infrastructure for a nanofab is crucial.
Welcome to the National Nanofabrication Center. Today, I'm going to take you on a tour that is going to show you what goes in planning such kind of infrastructure. Nanofabrication is a complex but not intimidating process. It requires lots of integration of various technologies, advanced technologies. To be able to house such technologies and such processes, you require special labs, you require special spaces. How do you think about creating these spaces and what kind of requirements it throws at you for architectural infrastructure? That's the goal of the tour today. I'm going to take you especially on this tour which explains 3 things. One is, how do you select appropriate location? Second, if you have the location for the nanofabrication facility, which is a clean room, how is that integrated with the rest of the infrastructure, which might be the parent building with associated labs? And what are the technical requirements that must be accommodated, such as vibration isolation or protection from electromagnetic interference? These are exacting requirements of nanofabrication that you must accommodate in your plan. So I will take you through all of these segments.
We can see that the NNFC is located on a large plot of land with plenty of greenery around it. But is there more than meets the eye? There were, after all, other available plots on campus. What were the important factors to consider before choosing the present site?
First, let's talk about location. What goes in deciding where to locate this kind of infrastructure? How much space do you need? And what you must be sensitive to when you locate this infrastructure. In our case, we decided that we needed 14,000 square feet area clean room. This kind of shell structure which houses the clean room is part of a bigger building, and the building itself is about 90,000 square feet. So the total area that we needed along with the building and the areas around it was about 5 acres. 5 acres of space, contiguous space, is not easy to find anywhere. In our campus, which is beautiful green campus, we had to be very, very sensitive to the biodiversity present on this campus. When you try to locate clean room infrastructure, perhaps the most critical factor that determines location is vibration isolation. It has to be away from major vibration sources. For example, at Oxford University, they had to spend a lot of time and money to locate their clean room in a place which was just next to a railway track, and therefore they had to do a lot more for isolating from the vibration of the track. Similarly, at EPFL Lausanne in Switzerland, they have their infrastructure which is very close to a metro station, and they had to go underground. They had to go below the ground to build the clean room infrastructure to protect themselves against vibrations.
To select a site with minimal vibrations from surroundings, the NNFC design team began by looking at the IISc campus map. The CEDT building with a vacant lot next to it seemed a good candidate.
This is one of the locations we considered very seriously for building our clean room infrastructure. What you see behind me is the building that is Center for Electronic Design and Technology. This center offered us the entire ground floor for associated labs and offices. And next to the building, as you can see, we have empty space which is about 15,000 square feet, just ideal for the clean room infrastructure. However, we had to forego this site because, as you can see, right next to it is this mini forest. This mini forest is home to a diverse set of species. We have birds, we have butterflies, snakes, other reptiles, as well as one of the endangered species, the slender loris. Slender loris is only found in this part of India and some parts of Sri Lanka. Because of this kind of biodiversity existing here, we started thinking that if the nanofab runs here, nanofab processes and all the machines running 24 hours a day will produce enough vibration, enough sound to disturb these species. And therefore, the obvious decision was not to build it here.
So the NNFC core design team took a second look at the IISc campus map. The lush green field behind the ECE building seemed ideal.
Next to me on the left is another great location that we were interested in. 5 acres of just bushes, no big trees to cut, and far away from traffic and roads. This was ideal for locating Nanofabrication Center. However, we were told by our Center for Ecological Sciences that these bushes are home to several species of butterflies. This is a sensitive habitat. So, we had no other option but to move away from here. We moved about 100 meters right in front where butterfly habitat isn't there, and we built our Nanofabrication Center there. You can see, you can hear crows in the background, leaves still fluttering, butterflies still thriving here. We, working over there 100 meters away, we all coexist peacefully.
After 2 years of scouting, the current location was considered fit for the NNFC's construction.
Where we are standing right now is the 5th and final location. This is the piece of land we selected to build our infrastructure. Here, the parent building, which houses the clean room shell, is located in a very convenient way away from the main road, which is about 300 meters from here. So we get least amount of vibration from the main road. Our water sources for bringing water to the clean room are located close by, and there was enough space in the back for building the utility building. This is why we selected this particular location. Right now, we are standing about here, which is on top of the clean room shell. Clean room shell is this long building which is integrated with the parent building, although there is an isolation that you cannot see here. So clean room shell is here and rest of the building is here.
Let's go inside the NNFC and look at how the final site has been transformed.
So we are at the final site, but this is inside that site, which you saw from above the building. Once we selected this site, we had to clear up the site for construction. This very area, which is for the clean room, looked like this when we started. There were a few trees which we did not cut, but we transplanted. As I have described to you, we have been very sensitive to the ecology around us. Once the site was cleared, the construction began. These are some of the pictures from the construction chronicle. And the final result is this clean room. This area is 14,000 square feet. What you see here is the wall of the clean room. Behind this is 10,000 square feet of clean space. This shell is structured in 3 layers. I will tell you more about it and why it is structured in 3 layers. We'll talk about that. But what you see now is the final result of site selection and execution of the plan.
The NNFC depends upon several ancillary facilities and structures in order to function. Let's look at how all these building blocks are integrated.
We are now in the back of the parent building. I brought you here specifically to show a few building blocks that are very important in the entire design. The building blocks are, one is the clean room itself that we have been talking about. That is located to my right. The clean room is supplied with all utilities from a utility building, which is a 3-floor building. We call it a stacked utility building or SUB. The SUB has to be located away from the clean room because SUB itself produces a lot of vibration that should not go to the clean room. We have located it about 20 meters away from the clean room. After you do processing in the clean room, typically you do a lot of characterization on devices. So we had to build a characterization facility with lots of sophisticated equipment that also have similar requirements on vibration isolation and EMI protection. The characterization facility is located on the other side of the parent building, and that is on the ground floor, slightly away from the clean room, because there are people who come to the characterization facility bringing devices from outside that are not necessarily done in our clean room. Now, next to the characterization facility, about 40 meters away is the power substation. That's the source of maximum EMI. The substation was located twice in our design because we were not happy with its proximity to the characterization facility. Once we got that location, which is about 40 meters away, we measured and we found that EMI was the least from there, and we could live with that kind of EMI for characterization equipment. We also have diesel generator set, which is right here. It's located again about 50 meters away from the characterization and far away from the clean room. The main consideration in locating the generator set here was the sound that the generator sets emit. We have bought generators which have 75 dB rating, which is very good. Yet we wanted to have about 50 dB in the work area, and that's why we calculated that how much distance we have to set it away so that the sound levels fall down within acceptable limits.
In designing the NNFC's architectural infrastructure, maximum attention has been paid to minimizing vibrations. Thus, the entire parent building has been isolated from its surroundings.
We are now in front of the parent building. This building houses the clean room on this side, and this building, complete building, is isolated from the vibrations of traffic, cars, buses, trucks, whatever, going on the roads close by this trench. This is the vibration isolation trench. I'm right now walking on the trench. This is a 2-meter deep trench, which is filled with just air. Air acts as an extremely soft spring. So the idea here is that whatever vibration is coming from the ground, that gets stopped right here and does not get transmitted to the right hand side or to the building. The way we do it is, you have concrete wall here, you have concrete wall here, because in here is a trench, so you need retaining walls, and these concrete blocks that you see here, these blocks are obviously for covering, but if these blocks are connected to the two sides, then the vibrations will get transmitted. There will be a short circuit. So what we do is, in between the wall and the block, we use rubber padding, and that's what prevents the vibrations from getting transmitted. This way, we protect the entire building from outside vibrations. Of course, I'll be telling you more in technical details about vibration isolation, and I'll show you how the clean room inside is isolated from rest of the building, and then how sensitive equipment are isolated from the clean room itself.
Preventing vibrations that cause equipment to shake is so critical that the clean room is further isolated from the parent building in multiple ways.
Inside the building, this is the clean room shell area, and this area is isolated from rest of the building with another trench just like the one you saw outside. I am actually standing right on top of that trench. So this trench is half a meter wide, 2 meter deep, and again we have a covering with steel net, but that is exactly put the way I explained outside, that it has rubber padding on both sides so that there is no short circuiting of vibrations. Here you can see that the floor itself is made of actually 1 meter depth graded material. This flooring is a special flooring so that vibrations which come from below the floor can be prevented from getting transmitted up. So this floor is actually made of several materials, which I can show you here. At the bottom of the floor, is a 50 thick anti-vibration rubber pad, 50 thick pad over the entire 14,000 square feet area. On top of that, we have 450 thick sand. Above that, we have 200 thick soling. Then we have 100 thick PCC, and then we have 200 thick RCC concrete, which is what you see on top. Even that RCC is cast in segments. You can see these lines here, the grid lines. These are denoting that the entire floor is set in segments, so that suppose if a pump is sitting here and this part of the floor is vibrating because of the pump, that does not get transmitted to the next panel. You can see columns here that support the ceiling. These columns are isolated from the rest of the flooring by having rubber pads around them and by providing completely different foundation for these columns. So we try to isolate vibrations as much as you can possibly do. No sideways vibration, no vibrations coming from the bottom. These vibrations typically arise from three sources. One, vehicular traffic that I talked to you about, and we isolate the building itself from that. The other is machinery which is inside the building or above the building. For example, on the roof, we have many blowers, air conditioning equipment that also produces vibration in the building. We have to prevent that vibration coming from here. You have also seismic vibration or vibrations of the building due to wind. Luckily, our building is just 2 floors high, at least on the clean room side, and therefore wind vibration is not a problem. Seismic vibration, Bangalore is a very safe place. It's in zone 2, and therefore we don't have to do too much to isolate, to make special arrangement for isolating from seismic vibrations. But frequencies or vibrations in frequency ranges from 1 to 50 hertz. That is what is dangerous for us, and we would like to avoid all those frequencies. We want vibration amplitudes of 3 micrometer per second and above to be cut off, to be isolated in the frequency range from 1 to 50 hertz. That's what we are preparing ourselves for, and this kind of vibration isolation qualifies you to what is known as VCE classification, which is used for semiconductor industry. That's the target we have, and that's why we are doing so much of isolation.
An important aspect of the NNFC's architecture is its 3-layered, top-to-bottom structure.
I wanted to explain something to you here, but this is steep incline from the floor of the sub-fab to the floor of the fab has me panting. So let me take you back to the floor of the sub-fab and explain to you why this steep incline exists here. As I walk down the incline, I'm going to go to the bottommost level of the 3-layered clean room structure. As you can see here, this is the bottommost floor. I've explained to you that this floor itself is made of 1.2 meter differently graded material. On top of that floor are these struts that support the entire clean room flooring. These struts are dense, as you can see, because they have to support a lot of weight of all tools and people who are going to work here on this floor. This is 1.2 meters in height. That's the height of the subfab, the bottommost level of the 3-tiered structure. Above this is the second level, which is the clean room. And as you can see, this is the ceiling of the clean room, and above the ceiling is the plenum, This is how the plenum looked like during construction. Let me show you this strut, which is right here, and this is how you can adjust its height, little bit of adjustability for height so that you can level the flooring. And I have a floor tile here. This floor tile, you can see here, it has a groove. All the floor tiles are located on this strut at corners. So there will be four floor tiles, and these floor tiles, four of them coming together, create a beautiful plain surface without any gaps. You can also see that it is perforated. Not all tiles are perforated, some are solid, but perforated floor tiles are provided for air to go through the perforations, go down in the subfab so that they can come back from the return chase up and be forced down again through the fan filter units. So this is how the entire flooring of the clean room is made. So we have down here, that's the level of the subfab, this is the level of the clean room, and 3 meters above is the level where the plenum starts.
The plenum, which is easily accessible from the mezzanine floor, is worth a visit. It houses many utilities and also supplies conditioned fresh air to the clean room below.
I am going to now enter on the other side of the clean room panel. I showed you that this is the clean room panel that is inside this cell. On the other side of this panel, there are 3 levels. The entire clean room consists of 3 levels. First is the subfab. Subfab is 1.2 meters in height. That is from the ground floor. And then above the subfab, we have the clean space, and that is 3 meters in height. Above the clean room area is the plenum, which is 3.8 meters in height. It is the third segment. It is the third compartment that I'm standing in. This plenum, as you can see, houses lots of utilities. It has several ducts that carry air, chilled air, exhaust, and also there are lots of gas lines which are running here. In fact, we use about 20 gases, and all the gas lines are running here. They service all the equipment downstairs. Now this plenum, as you can see, is suspended from the roof. The roof, by roof I mean the concrete roof. First, we have a thermal insulation layer. This thermal insulation layer is 19 mm thick. This layer is made up of a polymer-like, rubber-like material to insulate the concrete roof or ceiling, and below that we have 3 mm thick aluminum sheet. You can see that the plenum is suspended by stringers. These stringers, so these rods, are hooked to the concrete ceiling through hooks which are embedded in the concrete itself. Each stringer can take 500 kg of load. They are separated from each other at 1.2 meter. So it's a dense array of stringers because we need to support about 15 to 20 tons of the total load that you see here. That load also consists of in excess of 350 fan filter units and light fittings which you see down here. All of this is suspended on this plenum that is supported from the roof. Now we also have through the cutout, you can see the floor of the subfab. The subfab starts from the concrete floor that I showed you, which was explained when I was explaining vibration isolation. Above that is the subfab, and above the subfab starts the entire clean room. So now I have showed you all the three levels of this clean room. Of course, there are lots of services down in the subfab which run from the utility building, and that will be covered in another module.
The last major distinctive feature of the NNFC's architecture is the perimeter walkway on the ground floor as well as on the mezzanine floor.
I have already explained to you the three-layered clean room structure that exists to that side of this wall. Now I am going to show you the last architectural feature that we have incorporated in the cell, in the design of the shell to connect the clean room to the walls of the shell, and that is this catwalk. It houses these beauties. It's just that it requires technical training to see the beauty in them. This catwalk is a concrete cantilevered structure that extends up to the edge of the clean room panel. We have this perimeter walk all around, and we have doors in the panel on all four sides. These doors are provided for easy exit, and the shell itself has on three sides doors for fire exit. This kind of perimeter access is also provided on the clean room floor, and that gives visitors a place to go around and see the entire processes happening inside the clean room. This is a distinctive feature not just for safety and security, but also it allows us to store a few things on this floor. We call this mezzanine floor, and it has gas cabinets as well as chemical storage on the other side.
On this tour, Professor Rudra Pratap acquainted us with important architectural features of the NNFC. To learn more about other design aspects, please watch the remaining videos in this educational series. Thanks and goodbye from the NNFC.